At first glance, it looks like just another beautiful image of space. A sea of light, a crowded sky, a few bright stars in the foreground, and a haze of distant galaxies behind them. But stay with it for a moment, because this is not just a photograph. It is one of the first true glimpses from a machine built to change how humanity sees the universe. The Vera Rubin Observatory has just opened its eyes, and what it saw was so vast, so dense, and so overwhelmingly detailed that it immediately became clear. Astronomy has entered a different era. This is not just about sharper pictures. It is about building a living map of the sky so deep and so wide that the universe may finally stop looking like a collection of snapshots and start looking like a story in motion. The first thing you need to understand about the Rubin Observatory is its scale. This is not a normal telescope camera. It is the most powerful digital eye ever built for astronomy. A 3,200 megapixel monster roughly the size of a small car and weighing around 3,000 kilograms. To display a single full-resolution image, you would need hundreds of ultra-high-definition screens. Yet even that astonishing statistic barely captures what makes it extraordinary. This camera was not built simply to take one spectacular image. It was designed to watch the entire sky over and over again, night after night, until the universe begins revealing how it changes. Its first great image already hinted at that incredible power. What looked at first like a simple field of galaxies turned out to contain nearly 10 million galaxies packed into one breathtaking view. Some are graceful spirals. Some are giant elliptical galaxies glowing with ancient starlight. Others are distorted wrecks caught in the middle of violent mergers. Scattered in front of them are stars from our own Milky Way. Their sharp diffraction spikes are not caused by the stars themselves, but by the telescope's optical structure interacting with their light. In a single image, you are looking at the nearby foreground of our galaxy and a distant island universes billions of light-years away, all layered together into one remarkable cosmic cross-section. What makes this even more astonishing is how quickly Rubin achieved it. The image was assembled over just 7 nights using 1,185 individual exposures stitched together into one enormous field. That means the observatory is not only incredibly powerful but also extraordinarily efficient. A region of sky this large and this deep would take older telescopes an enormous amount of time to reproduce. Rubin is not simply taking better images. It is changing the speed at which the universe can be explored. One of the most remarkable scenes in Rubin's first observations lies in the southern region of the Virgo cluster, the nearest great gathering of galaxies to our Milky Way, located about 55 million light-years away. Within this enormous field, the observatory revealed a stunning mixture of galactic ages and personalities. Some galaxies shine with brilliant blue light, a signature of hot, young stars actively forming within their spiral arms. Others glow with softer yellow and red colors, evidence of much older stellar populations in galaxies that stopped forming stars long ago. In a single frame, you can see both youth and old age spread across the cosmos. There's Messier 49, a giant elliptical galaxy filled with ancient stars and wrapped in a soft golden glow. Nearby lies NGC 4535, a face-on spiral galaxy displaying vigorous star formation in its bright blue-white spiral arms. The image goes even deeper. Between the major galaxies are dwarf galaxies, massive ellipticals, delicate spirals, and faint reddish smudges so distant that they lie far beyond the Virgo cluster itself. Some of those background galaxies are more than 1 billion light-years away, appearing only as tiny red embers scattered across the darkness. Then comes one of the most dramatic features in the entire field, a triple galaxy merger. 3 galaxies are caught in the act of reshaping one another through gravity. Their original structures are being torn apart, stretched, and twisted into enormous tails, graceful arcs, and luminous bridges. This is not a peaceful sky. It is a battlefield of slow cosmic violence, and Rubin's observations make that immediately clear. That is one of the reasons these first images are so breathtaking. They are not static portraits. They are frozen moments in a universe that is constantly colliding, forming new stars, aging, evolving, and transforming. Then there's another remarkable detail that makes the Rubin Observatory seem almost alive. While it was observing the distant universe, objects from our own solar system quietly crossed the field of view. Hidden among the galaxies were asteroid trails, thin colored streaks left by small bodies moving during the long exposures. These were not imaging errors. They were real solar system objects quietly photobombing one of the deepest early images ever taken. Rubin's software is intelligent enough to identify those moving objects and remove them from the final stacked image, preserving a clean view of the distant universe while simultaneously flagging the asteroids for discovery. This is where the mission begins to feel almost unbelievable in its capabilities. In just 10 hours of observing, the Rubin Observatory detected nearly 2,100 new asteroids. Think about that. All other telescopes on Earth and in space combined typically discover around 20,000 asteroids in an entire year. Rubin found roughly 1/10 of that total in a single night. That means this observatory is not simply going to improve asteroid detection, it is going to transform it. The scientific implications are enormous.